Here we're looking at another example of solving these inequalities using the graphs. F of x is the red parabola, g of x is the blue line. We're not given the function of f and g, but we're asked to find where f is greater than g. In this example, we see that the f function is on top of the g function here, or essentially we're looking at the y values of the f function being greater than the y values on the g function, and we're being asked where is that happening. So we've highlighted the interval, but now we need to actually answer it in a mathy kind of way. So we would say, here's where that begins and here's where it ends. And we talk about where things are happening using x values, so we would say from x is equal to -3 to x is equal to 1, we are not going to include those endpoints because we're not allowed to have the y values be the same in part A, but in part B, the y values can be the same, so we are going to include those endpoints and say from x is equal to -3, including -3 satisfies it, to +1, and then including the 1. So for then part C, we're going to have a different region, so the y values here are supposed to be less than the y values on G, so f is below g down here, and f is below g down here. So the y values on those ordered pairs of f are less than the y values of the ordered pairs on g. So where's that happening? This is happening starting at x is equal to -infinity to x is equal to -3, not including it on part C, and then from 1 to +infinity. Again, these are x intervals, so from this region to -3, and then from 1 out to +infinity. And then on part D, we would include those transition points here and here, and say from -infinity to -3, include the x value now, from 1 to +infinity like this.